zeros of a polynomial. We have learned the definition for the zeros of a function. That is the same. So now our function becomes a polynomial function. Polynomial function. Zeros of polynomial function. Okay, so we say that definition x equals a is called a zero of a polynomial function f, a polynomial function f if f of a equals 0. Okay, so for the polynomial, we will have, look at this property. If a is a 0, then x minus a is a factor of this function f. What does this mean, a factor? A factor of this function f. This means this function f of x can be written as x minus a times something. Okay, times something. And if x minus a is a factor, then when x equals a, it becomes 0. So in other words, a0 is a what? Is an x-intercept. X-intercept of this function f. Okay, is an x-intercept of this function. So how to find the zeros of a polynomial function? It's very easy. We just set the function to be 0, then solve for x, right? So now we use the example. Find the zeros of negative 2x, f of x equals negative 2x to the fourth plus 2x squared. Okay, so how to find it? We just set f of x equals 0. So that means negative 2x to the fourth plus 2x squared equals 0. We solve this equation for x. So here is one thing, you cannot divide by 2x squared, because when you divide x squared, you will automatically assume that x is not 0. However, x is 0, x equals 0 is the solution, right? So you cannot do that. The only thing you can do is factorize it. Okay, so we take a common factor, negative 2x squared, out. So this one becomes x squared minus 1 equals 0. So you will have x squared, x minus 1, x plus 1. We can factorize this term, right? Equals 0. So here I used this one. We just remind you that a squared minus b squared equals what? A minus b times a plus b. Right, we factorize this part. So now this from here we can see, okay, so the zeros are, so we have the solution x equals 0 or x equals 1 or x equals negative 1. So these are the zeros we will make, right? But we notice that there is a very interesting thing, that this x equals 0, we have the x equals 0 is from this term, right? This term will have power 2. X equals 1 is from this term, but this term it has the power 1. And x equals negative 1, this term is power 1 from this one, right? Power 1. So now This is another definition, which is called the multiplicity. Another remark for this problem. We say a 0 x equals a has multiplicity k if x minus a to the k's power is a factor of this function f. So in other words, this function f can be written as x minus a to the power k times something, right? So for this example, we have, for the above example, then x equals 0. This is 0, but here is power 2. We see this x equals 0 has multiplicity 2. So that means you have two zeros, right? Make this function to be 0. So we denote it by m represents the multiplicity of this 0 equals 2. X equals 1. X equals 1, we only have x1, right? Only have 1 to make this function to be 0, so the power is 1 here, the power is 1 here, so this is has multiplicity 1. In other words, this m1 for this 0, which is 1, the multiplicity is 1. X equals -1, the same thing, has multiplicity 1 also. In other words, this m-1 has multiplicity 1. So why we are interested in the multiplicity? The reason is it will be very helpful to sketch the graph of the polynomial. So now let's look at the properties for the multiplicity. So now let's look at the first property. If the multiplicity k is an even number, is even like k equals 2, right? Then the graph touches x-axis at that 0. We see that 0 equals, for example, equals a, right? So in other words, the graph will look like if this is 0, right? This is x-intercept, right? 0 must be an x-intercept. This is a. So the graph, it will look like this one will touch it nearby. Okay, we don't know other behavior. We just say, okay, near this one, we will touch the we will see. Okay, let's draw much better. Okay, it will look like this one, right? Nearby a, it will touch the x-axis, or nearby a, it will touch the x-axis. Okay. if k is odd, then the graph will crosses x-axis at this point. Crosses x-axis at x equals a. If this is a, it will cross, or it will, this is a, cross, okay, cross this x-axis, cross at x-axis at this point. Two, the degree n polynomial function f has at most n real zeros. Okay, so for example, for this function, this is degree 4, then it has at most 4 zeros, but we only have 3 zeros. That's fine. At most, that means less than 4, right? At most means less than, equal to. Okay. So now let's look at, so this one gives you a very good property. Then this good property will help you to sketch the graph for this function, for this here, for this function f of x, which is negative 2 plus 2x squared, right? This is our function we already have that, right? We have x equals 0 is the 0, the multiplicity is 2. We just solve it right here. The multiplicity is 2. And we also have another 0, which is negative 1. The multiplicity is 1. And we have another 1, which is the multiplicity is 1. Right? So the idea is, let's locate the zeros, right? This is 0. This is negative 1. This is 1, right? We notice that the end behavior is determined by the first term, y equals negative 2 times x to the 4th. X to the 4th will go up, right? Negative number times x will go down. So the end behavior would be this one and this one, right? So our graph will look like, so here is the end behavior for this part when x is very small. So then go up. Okay, so here is multiplicity is 1, so we cross. Then if we drop to here, we must go down, right? Somewhere go down. And here multiplicity is 2, so we touch. So it should be smooth. There's no sharp corner, okay? It should be a very smooth curve. Then go up, so somewhere we must go down because we must go through this point, right? So the multiplicity is 1, so we go up. It's cross. So then we have, okay, so this is the sketch of the graph, right? So in other form here, you can see that when x is less than 1, this function would be a negative value, right, which is less than 0. When x is greater than -1, less than 0, so this is the greater than 0. Then this is the greater than 0, right, for the function value, and here the function value would be less than 0.